Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss locating tetrahedral and octahedral voids. Locating tetrahedral and octahedral voids. Last class I have discussed some numericals based on formula of a compound and number of voids filled. How to calculate? Last class I have discussed. Now I am going to discuss locating tetrahedral and octahedral voids. We know that close packed structures have both tetrahedral and octahedral voids. Close packed structure have both tetrahedral structure and octahedral voids. Both voids it has tetrahedral voids and octahedral voids. Now let us take CCP or FCC. CCP or FCC structure and locate these voids in it. First, we will locate tetrahedral voids. Locating tetrahedral voids first. After that, I will discuss locating octahedral voids. For this, you have to understand CCP lattice, CCP or FCC, face cubic centered, okay, or CCP, cubic centered packet, this packed CCP structure, okay, cubic closed packet, CCP, cubic closed packet, or FCC, face centered, face cubic centered, FCC. Then here unit cell is divided. Here unit cell is divided into 8 small cubes. This is the important point. Here unit cell is divided into 8 small cubes. And this just for this you can consider one unit cell you can consider just like a cube, one big cube you can take, and that you consider as a I can say unit cell. Now just you can cut it in 8. That big, little big, you can take as a one cube you take and consider as this is the one unit cell. Now just you can cut it in 8 pieces, okay, means you can make from one cube, from the one unit cell you can make 8 small cube you can make, okay. Then how will you make? You know that you have to first upper face you can give some mark, correct? Upper face of the cube, just in the middle you put one mark. 4 corner is already there. Between the 2 corner in the middle, again you make one mark every side. Then just upside 4 mark was there, original big unit, 4 corner was there, and in the middle one mark, middle of the 2 corner, each corner in the middle, again you give one mark, one corner. Then everywhere now you will find 3 point, 3 point, two in the original corner and one in the middle, 3 one side, like that way. Other side again in the middle one is there, then 3 3 3 3. Then again you can say that you have done in the upper face, like that way. You can make left side same things. You can make left side, right side, correct, same thing you can do, and north side, south side, correct. All faces you can do same things, up down, correct. You can give the mark up down, upper face, down face, north face, south face, east face, west face. Give same mark everywhere, and then you can cut it also. You can cut it also, then you will get 4 cube. Then you will find after cutting also you can arrange it in 1. After cutting in 4 you got total 8 you will get. Total 8 you will get if you will cut it, correct. From the middle you will cut it. You have already given mark, then you will get total 8. Total 8 cell, unit cell you will get. A small cube you will find in the form of a small cube, 8. Okay. Then now just you arrange it. Again, after cutting again you can arrange it. Okay. Or if you can understand why this diagram, what I told you, then that is also okay. And also just you consider, imagine hollow, that big unit cell was, suppose it was you can say transparent. Transparent you can consider, everywhere you can see. Then after imagination or by cutting, better you do imagination what I told you, just for understanding purpose. That one big unit cell now you divided into 8 small cubes, that you just consider. Then out of 8 any one cube you take, and this you can say on this cube, alternative 11 point, 11 atom or cell, suppose it is there. Alternative corner, suppose 11 cell, 11 sphere is there, means atom is there, atom or molecule or ion. Suppose alternate corner, 1 this sphere is there. Then one cube you are considering, then one corner, one sphere. After that second corner no. Again third corner you have put, fourth corner no. Means then diagonally you will find you have kept one corner 1, second corner no, third again you have kept, fourth no. Then upside 2 sphere you have kept. Down also if you will consider like that, keep, then 1 2 more you can keep. Alternate you keep a sphere, alternate corner. Then after doing this, means upside 2 is there, then like that way if you will keep alternate, then 2 more you can keep. Then you will see, then it is a diagonal. Arrangement will be diagonal, because first and third upside and down again you will keep, automatically it will be diagonal. Okay, means you have kept first and third, then like that way down again you can keep you can say third, fifth, and this 6, 7. Okay, this diagonal, what you was upside diagonally, that down again it will diagonally, but opposite way, not in the like up. Up you have said no, that diagonally 1 and 3rd. But there you will put then there you will put that 3rd, 4th, 5th, 6th, this 7th. It will be again diagonal. 1st, 2nd, 3rd, 4th, 5th, and after that you will find 8, 5th and 6, 7, 8. Okay, 5th and 8 means what was the direction wise upside, that it will be down just other way, opposite of this, because you can arrange 1st and 3rd and 2 and 4 also, but just like 2 and 4, down is down will be 5th and 8, okay, opposite. Then here you have seen that one cube, on one cube, a small cube, total 4 sphere is there, means 4 atoms are arranged and all are at alternate corner. Okay, then like that way, if you will arrange all, suppose all 8 cubes again you have kept in one place, just like a original unit cell was there, you have arranged in that way only. After cutting you have arranged in the original form. Okay, then now again it will become big unit cell. This figure you keep in your mind, then all things you will understand. Total 8 small cubes are there. You have made big cube, big unit cell. You have just arranged. Then you have arranged in such a way that now it is appearing like one big unit cell. This you have to keep in your mind, imagine like that. If diagram is there, you can imagine like that. Okay, then each small cube has atoms at alternate corners. In all, each small unit has 4 atoms. Correct? In all, each small cube has 4 atoms. When joined to each other, they make a regular tetrahedron. All sphere, if you will join in any cube, or any one cube, not in all 8, any one cube, then it will form regular tetrahedron. There is one tetrahedral void in each small cube. This is important things. There is one tetrahedral void means a gap, in each small cube, and 8 tetrahedral voids in total, because total 8 cubes are there. Then total 8 tetrahedral void will be there. Total 8. In total there will be 8 tetrahedral void. Each cube has one tetrahedral void. Then 8 cube will have 8 tetrahedral void. Okay, and each of the 8 small cubes have one void each. Then obviously 8 are there, then 8 tetrahedral void will be there. Now we know that CCP structure has 4 atoms per unit cell. CCPS structure has 4 atoms per unit cell. Thus, the number of tetrahedral void total in big you have seen total 8, and in one cube 4 atoms are there. CCPS structure has 4 atoms per unit cell. Thus, the number of tetrahedral voids is twice the number of atoms. Okay, means each cube you have considered. That alternate you can say atoms are there. Each corner alternate atoms are there. Then in one cube 4 are there. 4 atoms are there. Okay, these things only you have to understand. Then total 8 cubes you have made. Then 4 into 2, 8. 4 into 2, that is the 8. Then here you can understand now that the number of tetrahedral void is twice the number of atoms. Means 4 you have kept in one cube, 4 was there, but in total in a bigger unit cell it was 8. Correct? 8 tetrahedral void is there in 8 cubes, but in one cube total 4 atom was there. That's why 4 into 2, 8. Thus, the number of tetrahedral void is twice the number of atoms. Okay. Then here you have seen tetrahedral void is twice the number of atoms. This is the important things. Twice the number of atoms. If 2 have considered, then total 8 is there. Twice of the number of atoms. This I have told you 8 tetrahedral voids per unit cell of CCPS structure you have seen, and 1 tetrahedral voids you can say surrounding the geometry. Okay, means 4 into 8, 4 into 2, that is the 8. This you have to understand. Okay, I will try to send the this diagram also. This is a very ordinary diagram that now already I have discussed that one big you have cut it into the 8 pieces, 8 cubes. Okay, then one cube you can understand, you consider any one cube and all you can say atoms joined to each other, then it will form a tetrahedral structure. Now second things I am going to discuss, locating octahedral voids. Octahedral 6. Then here same diagram you have to consider. What I have discussed, big big unit cell you have divided into 8. A small cube. Same diagram you have to imagine, consider. Now you think that all are transparent. All 8 are transparent, and every corner, alternate corner, one sphere is there. What I discussed, same way here also you have to consider. Then now what you will see that if you can say that each just suppose that on face you have considered this one unit cell, big unit cell you have considered, then in the center of the one phase, each phase, suppose this atom is there. Obviously, if you will join all eight, then you will find that in the middle of the cube, each phase in the middle of a unit cell, big unit cell, one atom is coming. Obviously, because in the beginning I told you, every corner, alternate corner, you have to put one atom. Then you will find in a big unit cell, in the corner, each phase in the center, one atom is there automatically. You will see, you will find on each phase of the big unit cell, one atom is there. Means you will find that total 6 phase will be there in a cube. 6 phase is there. Then 6 atom will be there middle. On each phase in the center, one atom will be there. The total 6 atom. Then now you think hollow, you consider just like a hollow, all things are hollow, okay, and it is a transparent. That you have to consider. You consider that a big unit is there, suppose it is a complete hollow, okay, just to think. And in the body center, you know that in the center of the full this unit cell, one atom will be there. I already discussed that body centered means like that. In the center of the cube, one particle will be there, one atom will be there, correct? And surrounding this, total 6 atom will be there. Of each phase, one atom in the center. But here what you have to think, that on each phase 6 atoms are there. But in the body center, don't think that atom is there. Don't consider that in the body center, in the center of the body, consider there is no atom, but surrounding 6 are there. Okay, but in the body center, no atom is there. That you have to think. Then it is forming hexagonal. I have briefed you. Now I am telling you little details. Okay. Then already told you, again consider a unit cell of CCP or FCC lattice. The body center of the cube is not occupied. Okay. Body center, suppose a particle was there, generally we are keeping C. Now suppose C is not there. C is not occupied, but it is surrounded by 6 atoms on face center of these face. Okay. C is not occupied means center, no is not occupied means atom is not there, but it is surrounded by 6 atoms on face centers. And if these face centers are joined, okay, because on each face one in the center one atom is there. Then if these face centers are joined, an octahedral is generated. Thus, this unit cell has one octahedral void at the body center of the cube. Because in the center nothing is there, then there will be void. It means one octahedral void at the body center of the cube. It is generated. Okay. This unit cell has one octahedral void at the body center of the cube, because there is no particles, no atom. Now again you can see beside the body center, there is a one octahedral void at the center of each of the 12 edge. 12 edge. You will think, where is the 12 edge? Actually, here you have seen. Now, beside the body center, there is a one octahedral void at the center of each of 12 edge. In a whole big unit, or this big unit cell you have considered, there you have divided into 8 cubes. Then you will, if you will count any face you count, any one face you count, then you will find that there are 8 edge, because upside there are 4 cube, you have divided into 8, 4 up and 4 down. Then one face you count, how many edges there? Then it will be 12. It will be 12. Okay, 12 edge will be there. And because on each cube, that is the last you can consider outside, one face is there. Again, down one cube is there, two face. Again, you can say total 8 cubes are there. Then 4 cube. 4 cube means outside you can see. 4 cube you can see from outside. Then 4, that 2 are up, 2 are down. Then now side you count, how many sides are there? Then 1 and 2. In the beginning 1 and 2, after the middle again you will count, then 2 will come. And again in the last 2 will come. Then 2, 2, 2, 6. 2, again in the middle 2, and again in the last 2, total 6 sides. And now again from the upside you count, then upside 2, again in the middle 2, and again in the last 2. Then total 6 plus 6, 12 edges are there, 12 sides are there, 12 edges are there. And each side means 12 edges are there, 12 edge. Then 12 edge is there, and it is surrounded by each edge is surrounded by 6 atoms. It is surrounded by 6 atoms. Okay. Then already I told you 4 belong to the you can say same unit cell. Okay. 2 on the corners and 2 on face centered, and 2 belonging to the 2 adjacent unit cells. Already I have discussed same way towards total 12. Since each side of the cube is shared between 4 adjacent unit cells. Here 2 things you have to understand, that 12 edges are there and it is surrounded by 6 atoms. Each edge. 12 edges are there and it is surrounded by 6 atoms. And second important point, that since each edge of the cube is shared between 4 adjacent unit cell, so it is so is the octahedral void located on it. Means here 4, one edge is shared by 4. By 4 you can say 4 cube or 4 unit you can tell. One edge is shared by 4 units. Then 4 units are making one void. 4 units are making one void. This 4 edge. Then one edge, how much? What is the contribution for one edge? 1/4. Okay. Then here I told you only 1/4 of each void belongs to a particular unit cell. Correct? Because this for one void, four this is required. 4 unit cell is required to make one void. 4 unit cell is required to make one void. Then 1/4 of each void, 1/4 is the contribution of each voids belonging to a particular unit cell. Means one unit cell is contribution is 1/4. Because for one void, to make one void, 4 unit cell is required. Correct? Then what is the contribution of each unit? 1/4. And in a practical way, I am telling you, you can understand well. Suppose you have taken 3 sphere. 3 sphere you have taken and you have brought it close. Then obviously in the center one void is there. And one sphere you put on that hole, 1/4 one you have put. Then now total 4 sphere. Then 4 sphere is making one hole in the middle. Now you can't see. 3 you have kept. In the middle of the 3 one void was there, that you covered with 4th one from the upside. Then now for one void 4 are required. 4 cell is required. Correct? Then what is the contribution of each cell? Then 1/4. Like that way. 4 unit cell is making 4 unit cell. Okay, is making one void. Then what is the contribution? Each unit cell 1/4 void. In making one void, 1/4 is required by one per unit cell. Okay, this is the important thing, sir. 1/4 of each void belongs to a particular unit cell. Okay. Then this is very clearly octahedral void also I told you, and tetrahedral voids also I have told you. Then only in one structure both will be present, tetrahedral also and octahedral also. Only in one crystal, or one unit cell, both are possible, both are present, tetrahedral also and octahedral also. Thus, in a cubic closed packed structure means CCP, octahedral voids at the body center. First you told only one in one concept, you have seen that in the body center no atom was there. Then only one void was there. Okay. Then octahedral voids at the body center of the cube is equal to 1. At the body center is 1. Now other you have seen 12 edge is there. 12 edge. Then due to that edge also octahedral void is there, due to that 12 also. Then 12 octahedral voids located at each edge. At each edge 12 octahedral voids are located. 12 octahedral voids located at each edge, and each edge is shared, you know that each edge is shared between 4 unit cell. 4 unit cell. Then now very easily you can understand that each 4 has you can say 1/4 contribution, or you can say one cell has 1/4 contribution, 1/4 contribution. Then 12 age is there, 12 age. Then 12 age means each age belong to 1 cubic cell, correct? Then this each cube has 1/4 contribution. Then 12 age, how much contribution? 12 into 1/4. Okay. Each this you can understand, each cell, I already told you, has 1/4 contribution, void, 1/4 voids. Then 12, how many? 12, how many? Then 12 into 1/4. 12 cell total will, one cell have 1/4 contribution. Then 12 cell, 12 into 1/4 means 3, that is equal to 3. Then here see 12 age makes 3 voids, 12 into 1/4, 3 voids. Then total voids, 1 due to the body center and these 3 due to the 12th age. Hence 3 and 1, body center 1, and now 3, total 4. Okay, then total number of octahedral voids is equal to 4. 1 plus 3, 4. Because each corner, each edge is surrounded by 4. Don't forget. Each edge is surrounded by 4 cube. Correct? And already in the case you have seen that it is making hexagonal. Just like a body-centered hexagonal you have seen, like that way, if a big cell you will consider, then you will find again they are making same way hexagonal they are making. Hexagonal. Correct? That's why their total number of, when you have considered 1 unit cell, you have considered in that total number of how many octahedral voids will be there? Then total 4. Okay. Then this in CCPS structure, each unit cell has 4 atoms we know. Thus the number of octahedral voids is equal to this number, means total 4. Okay. 4 atoms, 4 octahedral in a simple way. This I have discussed. Now I am going to tell other things which is very, very important. That is actually, it is a fully, you can tell, calculation, and that is called packing efficiency. Packing efficiency. What is actually packing efficiency? This you will understand very easily. It is fully calculation. Only one diagram. There are actually 3 cases are there. 3 calculation is there. Okay. That 3 total 3 are there. And one more is there, total 4 is there. That calculation is little different, and 3 is somewhat similar. Okay, total 4 are there calculation. That is called packing efficiency. Okay, then in out of this, today I will discuss only one because time is not sufficient. Okay, then here you have to understand the diagram. Once the diagram you will understand, all things are very easy. Okay, then here packing efficiency. What is this? First you understand. Out of 4, only one today I will discuss. In whatever way the constituent particles, that is the atoms, molecules or ions, are packed, there is always some free space in the form of voids. That is called packing efficiency. This free space or void, that is called packing efficiency. Packing efficiency is these voids are there. Then these voids are there, this is a gap that you should not consider. Then how many particles are arranged? Because some void will be there. Then void is useless. That you are only just it is free. There molecules and atoms will be not there. Then volume will be more. Total volume will be more. But the volume occupied by the atoms will be less. Understood? Volume will be more, but full volumes are not going to be occupied by atoms. Some gaps are there. Then atoms are using less volume, but altogether it requires more volume. Then actual volume occupied by the atoms or molecules or ions is less than comparison to the total volume. This you have to consider. Then packing efficiency is the percentage of total space filled by the particles. Correct? That is called packing efficiency. 2 marks question they can ask. What is the packing efficiency? Then packing efficiency is the percentage of total space filled by the particles. Okay. Now how we will calculate? Let us calculate the packing efficiency in different types of structure. Then first structure only I will discuss today. Okay, there are total 4 I am telling you. Then 3 are similar, 4th one is different. And many questions are asked because it is coming under difficult question. But I think now we will understand and quickly we will answer also without any problem. But here only you have to understand the diagram. Then here just you think one cube. Here you consider one cube. Okay. And in one face, in that cube 6 faces are there. Then consider only one face. And in that face, you consider that diagonally 3 atoms are placed. Diagonally 3 atoms are placed. Then face you can write A, B, C, D. A, B, C, D. One face only you consider. Only one face. 6 faces are there. One face you consider. A, B, C, D. Then A and C is a diagonal. A, B, C and D. Then A and C. AC you can join. And that is diagonal. Then in that diagonal you consider that 3 atoms are placed diagonally. Correct? 3 spheres are there on diagonal. This you have to consider. And also what you have to consider that radius small r you can consider. All are suppose all are equal sphere, and r is the radius. Then you know that in one sphere 2 radius will be there, r and diameter. Diameter means 2 into r, 2 into radius, that is the diameter. Then total diameter in one diameter means 2r. Then in the middle of the sphere, its length will be 2r. Correct? And for A and C, on the corner A and C, one is again there. sphere, then now you can understand contribution. Then what you will see that at the corner, means A, you first consider A is one sphere, then fully it is not within this space, it is going up also. This sphere is you can say only one R is in this space, only R. Okay, not full, 2R is not there. That is going to the other sphere. It is contributing to the other. Okay, that you have to think. Means its contribution is left side also, right side also, upside, every direction its contribution is there. Correct? Means A is the center, a sphere which is kept on A, then A is the center. Then below the center, which is coming under this face A, B, C, D, then only 1 R, not the full 2 R, not the diameter, because that is going to the, suppose on this cube other cube is there, correct? Then it is contributing to the other cube which is upside kept. But now here you don't consider, you consider only one cube. Then you can think that okay, this A sphere, that is only you can say down, only R is coming down, other R upside, it is contributing to the other cube. But now you have not kept other cube, is not considered, only one cube you consider now. Then role is only for 1 R. Then total, what is the length of the total diagonal? Then 2R in the middle, 2R, and 1 R upside A, near the A sphere, 1 R, and down C, near that also 1 R, not full 2 R. Then total distance is 4 R, 2 due to the central atom, that is a fully, it is in that phase, but A and C has just a partial, only R is coming, A, R and C, near C atom, that a sphere, R contribution. Then because it is in one line, then full diagonal length is 4R, 1 R due to A, 2 R due to the middle atom, and 1 R in the you can say C corner, one sphere was there, the total 4 R, diagonal length is 4 R. Okay, this you have considered main things. Now you also consider, you already know that each length, because it is a cube, then each length is equal. Then now you consider each length is a centimeter, a small a centimeter, correct? And each cube length is a centimeter. Only diagonal is 4 R centimeter. Only 4 R you can write. These two important point, cube a centimeter, each cube has a edge or length a centimeter, correct? Then now here you consider one triangle. It is making two triangle because diagonal is there on the face. Then only one triangle you consider, means A, B and C. Diagonal is there, that is AC is the diagonal. Then A and you joined, then ADC. This is the one triangle only you can consider. You know that diagonal can make two triangle, you know already, because it is a square. Then one only you consider triangle ADC. Okay, AC is the diagonal and AD is the perpendicular and DC is the base. Correct? AD is the perpendicular, DC is the base, and AC is the diagonal. This triangle you consider triangle ADC. Okay, now I am going little details. Okay, then now just you consider cube. Both type of close packing means HCP or CCP are equally efficient. These things you first you know that both types of close packing, that is a HCP hexagonal close packing and cubic close packing, both are equally efficient. And let us now I am going to let us calculate the efficiency of packing in CCP structure. Okay, then already a structure I have told you. Now just to consider triangle, any triangle ADC you consider or ABC you consider, both are same. Okay, ABC also, then AB, suppose if it is the base, then AC, then if AB is the you can say base, then BC will be perpendicular, correct, and AC is the diagonal. Any one triangle you can consider. Okay, then now suppose you are considering for your simplicity ABC, triangle ABC, then you know that this diagonal AC formula, you know that AC square AC whole square means diagonal square, that is the H hypotenuse you are telling na, H square is equal to B square, H square is equal to B square plus A square, means length square plus breadth square. If this formula you know, hypotenuse square is equal to perpendicular square plus base square. This formula you are going to use means H square is equal to perpendicular square plus base square. Then here you know H now you know that is the hypotenuse, and hypotenuse is equal to hypotenuse square, that is equal to A square plus A square, because length and breadth both are equal. Hence H square is equal to A square plus A square, means 2A square. Then here you consider now that that AC square is equal to 2A square, AC square. Then AC square is equal to 2A square. Then what is the value of AC? Then under root 2A square, means root 2 into A. That is the actually this is a hypotenuse value under root 2 into A, because hypotenuse square is equal to A square plus A square. Length and breadth both are equal for a cube. Then 2A square is equal to H square. Then H is equal to under root 2 into A. And already I have told you that if R is the radius of the sphere, then hypotenuse value you are knowing, H is equal to 4R. H is equal to 4R. It means 4R is equal to under root 2A. 4R is equal to under root 2A. Then now you can get both value, R value if you want. If you want R value, then R is equal to what? Under root 2 into A divided by 4. Correct? Now you will get R value. R value is equal to under root 2 into A divided by 4. Means you will get A divided by under root 2 into root 2 after the solution, because 4 is down and root 2 is up. Then 4 you can write 2 into 2 and 1 2 means root 2 into root 2. Then 1 root 2 will cancel. Down 2 into root 2 will be remaining. Upside A will be there. means A divided by 2 into under root 2. That is the R value. And if you want to know the A value, then 4R is equal to under root 2A. Then what is the value of A? Then 4R divided by root 2. Very simple way. 4R divided by root 2. It means you will get, after the simplification, that is equal to 2 into under root 2R. Correct? 2 into under root 2R. Then here A value also you are knowing, means side of the cube you are knowing in terms of R. Then side of the cube also you are knowing. Side is A you have considered, means A value you are knowing, and R value in term of A also you are knowing. A and R both value you are knowing, means radius value you are knowing, and cube side, one side cube value A also you are knowing. Now after that all things are easy. All things are easy. Volume of cube, you know. Volume of the cube, you know. What is the volume? AQ. AQ is the volume. Volume of the cube, you know. Length into breadth into height, all are equal. A into A into A, AQ. And A value you are knowing. A value you are knowing. The what is the total volume of the cube? Quickly will consider 2 into under root 2R power 3. Power 3. Then this you have considered the volume of the cube. Now here total volume of the sphere, how much is there? How much sphere? This is the total volume of the sphere. Formula you know. 4 by 3 RQ. 4 by 3 RQ, that formula you know. Correct? This 4 by 3 RQ, that is the volume of a sphere. Volume of a sphere is 4 by 3, you can say pi r cube. 4 by 3 pi r cube. That formula you know. Then here one thing you have to understand, that we know that each unit cell in CCPS structure has effectively 4 sphere. 4 sphere is there. That only you have to understand, that each unit cell in CCPS structure has effectively 4 spheres. 4 spheres. Okay. And then what will be the total sphere, volume of the total sphere? Then one sphere volume will be 4 by 3 pi r cube. Then 4 sphere volume will be 4 into you have to multiply it by 4. 4 into 4 by 3 pi r cube. This is the total volume of 4 sphere. Okay, is equal to 4 into 4 by 3 pi r cube. And this cube volume already you have calculated, cube. Then A cube, A power 3. Then that is equal to 2 into under root 2R power 3. Correct? These two value you are going to use in formula. Packing efficiency formula is there. Packing efficiency, what is the formula? Very easy formula. That is the volume occupied by 4 spheres in the unit cell divided by total volume of the unit cell into 100. Upside 100 you multiply. This is the packing efficiency. This is a simple formula. That is you can say out of 10 you got 8. Then what is the percentage? Out of 10 you got 8. Then 8 by 10 into 100, that is a percentage. Like that way, total what was the volume? In that how much was the, you can say volume, real volume occupied by the atoms or molecules or ions? That will be less. Obviously that volume will be the less than the total. That's why volume occupied by 4 spheres means 4 atoms. Volume occupied by 4 spheres in the unit cell into 100 divided by total volume occupied by 1 unit cell. Then what was the total, you can say, volume of the unit cell? Then both value already you have calculated. That value you put in this formula. Then volume of the occupied by 4 spheres, that is the 4 into 4 by 3 pi r cube into 100 divided by, that is the total volume we have calculated, 2 into under root 2r power 3. Correct? Both value we have put here. Then after simplification, you will get, after putting all this value, if you will simplify, then its value will come 74%. 74%. In a simple way, I tell you, out of 10, you got 8. Then in 1, 8 by 10, then 100, you multiply by 100. Then here, all volume, you are knowing that volume occupied by 4 spheres. That you are knowing, that is the total, that volume means volume of the atoms, you can tell, divided by total volume of the unit cell. Then you will get 74%. Then now I am stopping only here. Next class, rest things I will discuss. Actually, this is coming under very tough, and always in IIT or in medical less, generally in IIT advanced level, they will ask this type of question. It is considered as a difficult question. But I think now we have understood. Only this is simply little long. Three calculation is there. One for radius calculation, other for side calculation, and after that you put in the formula. Packing efficiency formula is that, in that you put, you will get the result. Generally in advanced level this question is asked, but they can ask in other exam also, in other way also. Okay, now I am stopping only here. Thank you.